Today our topic is isosceles and equilateral triangles. So our essential question is, how can I use theorems about isosceles and equilateral triangles? First off, before we move on into the theorems, we want to talk about the pieces of an isosceles triangle. So our angles, we have the top angle is called the vertex angle. And then the bottom two angles, which are congruent, are called the base angles. The two sides that are congruent are called the legs. And then the bottom that is between the two base angles is called the base. Our two theorems for isosceles triangles is that if two sides of a triangle are congruent, then the angles opposite them are congruent. So Base Angles Theorem. So if we know that the two legs are congruent, if we know that we have an isosceles triangle, then we can say that the angles, the base angles, are congruent. Then there's the converse of the Base Angles Theorem, which says if two angles of a triangle are congruent, then the sides opposite of them are congruent. So if we know that the base angles are congruent, then we can say that the sides, the legs, are congruent. Example 1. If HG is congruent to HK, so right here we're looking at this triangle. So if HG is congruent to HK, then we could say that angle G is congruent to angle, and we want to say HKG because we want to make sure we're talking about that angle, not this angle. So if we just put angle K, it wouldn't work because there are two angles at the vertex K. Oh, jeez. And then the second question, if angle KHJ, this angle right here, is congruent to angle KJH, this angle right here, then using the converse of our Base Angles Theorem, we can say that the two legs of that triangle are congruent. So KJ is congruent to KH. And when we're talking congruency, we need the lines on top because we're talking about the segments being congruent to each other. Corollary to the Base Angles Theorem is if a triangle is equilateral, then it is equiangular. So if we know that all three sides are congruent, then we know all three angles are congruent. And if it's equiangular, then all the angles are 60 degrees. Corollary to the converse of the Base Angles Theorem, if a triangle is equiangular, then it is equilateral. So if we know that all the sides are the same, we can say all the angles are the same. If we know all the angles are the same, then we can say all the sides are the same. So find ST in the triangle at the right. Well, we see that all three angles are congruent, which means all three sides are congruent, which means ST is equal to 5, because that would be the length of the sides of the triangle. Example 3, find the values of x and y in the diagram. So if we look here, we have equiangular triangle, which means we have an equilateral triangle, which means all the sides are going to be the same. So y is going to be equal to 4, because we have the sides of the triangle there. So this would be 4, that's 4, and this would be 4. And then we also have another triangle here that has the two base angles that are congruent. So we know that the two legs are also congruent. So we know that x plus 1 is going to be equal to 4, so x is equal to 3. Last example here, we have example 4, lifeguard tower. In the lifeguard tower, PS is congruent to QR. So there's PS and there's QR. They're congruent. And angle QPS is congruent to angle PQR. This angle right here is congruent to this angle right here. What congruence postulate can you use to prove that triangle QPS is congruent to triangle PQR? So let's find where those triangles are. Triangle QPS. This triangle right here. And then PQR would be right here. So if we separate them out, draw the triangles, we're told that PS is congruent to QR. So we know those two sides are congruent. We also know that they share a side. They share side PQ. So PQ is going to be congruent to itself. And then we were told that this angle is congruent to this angle right here. So if we're looking at it, we have side, angle, side. For questions B and C, I'd like you to think about them at home, and then we will go over them at the beginning of class, next class period. Thank you for watching this video, and please subscribe to my YouTube channel.